In this video, we're going to focus on the way we do compute today, and a lot of that discussion is focused on the processor. So we're going to really talk about different processors, from CPUs to GPGPUs to FPGA and some Atom and some other things. So CPU, of course, let's get some of the basic definitions, is a central processing unit. A GPGPU is a general purpose graphics processing unit, and of course the field programmable gate array is the FPGA. And all of these provide compute power, processing capabilities within our servers and our compute environments. This is a critical thing to understand, because as we move into the future, our objective is to get faster performance from these items, right, from the processor, from the graphics, and be able to deliver information in a more optimized fashion, as well as be able to drive down cost associated with servers and hardware and things of that nature. So let's talk about some of the key attributes here of a CPU. A CPU, remember, works as processes. It's very focused, done a great job. It hits process 1, 2, and 3, and it's fed by software, and it just knocks out. A GPGPU really started off as a graphics processor, and then it kind of turned into this general purpose processor here, and it's very easy to deploy and somewhat customizable. Whereas an FPGA is very customizable, very programmable through software, of course, that allows you to literally configure that processor to do anything that you want it to do based on I/O. And you can actually configure it down at the function as well as the path level, so that's pretty cool. Now, what we've seen here in the recent past is a combination of chips, like, for example, the GPU and the CPU together, combining both of these chips onto the same chip so that we can optimize performance, get more mass, and lower cost. And so you see this as kind of a predecessor of what the future holds for compute. So when we add both of those together, AMD actually calls this an APU, right? And so, or an accelerated processing unit is what they mean, and or advanced processing unit is the APU itself. So we put together the CPU and the GPU to equal an APU. So if you hear that term, that's what that means. But let's not forget the common technologies that all feed into what we call a heterogeneous compute environment. And again, this is the way the future is going for compute, so that we can do more with less. And of course, a great example of this, it would be ARM, Atom, SOC. Here, technologies that are typically used within a mobile infrastructure, right, where you have everything on a chip, for example, or running at a lower horsepower with the Atom and ARM processors, or you have, of course, system on chip with your SOC. All of these designed to lower costs and combine this heterogeneous compute environment. So to become a reality, we have to understand kind of where the central processor, the graphic processor, all work. Do we need the programmability of the FPGA? And how do we combine these? APU as being an example. But how do we combine all of this? See other videos on more details around this topic.